For number 4a, we need to find the antiderivative of this function. And this is one that is just a common form that needs to be recognized. So what you need to know for this is that the derivative of arctangent of x is always equal to 1 over 1 plus x squared. So this is just a derivative of a trig function that you need to know. And we're going to use that to answer this question. So we need to find the antiderivative of this. So we're going backwards. This looks pretty close to our formula. In fact, the only difference is we have a change of variable, obviously, so this would be in terms of t. But we have a constant multiplied on top. Remember, though, that constants, just like with regular derivatives and with antiderivatives too, constants just stay multiplied times the rest of the function. So if we consider this like 4 times 1 over t squared plus 1, we can do the antiderivative of this really simply. So if this is f of x, then capital F, the antiderivative, would still have the 4. And the antiderivative of this is just arctan of t. But remember that you always have to add plus c because there could have been a constant that when you took the derivative it would have disappeared. So here is our antiderivative of part A. In part B we have a factored polynomial and we need to do the antiderivative of it. So remember that at least in your course in Calc 1 we don't have any sort of product rule or anything for antiderivatives. How we have to solve this is in any case you see something like this where you have a product or a quotient. There's some either formula that you have memorized that lets you take the antiderivative of that, or you need to expand it first. And that in this problem, that second case is what's going on here. So we need to expand this, so we're just going to FOIL this. We get 2y squared here. We get minus 2y plus y, so that would just be minus y. And minus 1 plus 1, minus 1. So if we get this into all the individual polynomial terms, it just looks like this. And to take the antiderivative of this now is simple because we just use the power rule each time. So the antiderivative of 2y squared is 2y cubed over 3. Because remember, constants stay there. And to do the antiderivative of any basic power of a variable, you raise the power by 1 and divide by that new power. So the antiderivative of y would be minus y squared over 2. And the antiderivative of 1 would be y. And we always tack on our plus c. So that's our antiderivative here of that factored polynomial. In number 12, part C, again we're doing the antiderivative, and again we have something that's already factored. So we can't do the antiderivative like this because we have a product and we can't really deal with that in antiderivatives. So we're always going to have to distribute first. So our function is secant squared of x, secant times secant, minus secant x tan x. So now we have two terms. We could take the antiderivative of each one, provided that you know your trig antiderivatives and derivatives. So this problem basically just comes down to memorizing your trig derivatives. So if this is f of x, we need to find capital F, the antiderivative of this. So you don't need to necessarily remember them in both directions. Just think about the derivative of what is secant squared. So the derivative of tangent is secant squared. So the antiderivative of secant squared would be tan. And what's derivative is secant tangent. That's the derivative of secant. So the antiderivative of secant tangent must be secant x. So if you went in reverse and derived this, you would get here, and that's what we need. Just remember that you always have to put on the plus c if you're doing indefinite or regular antiderivatives or an indefinite integral. Finally, the last part of problem 12, letter D, we're taking the antiderivative of the following fraction, secant x minus tangent x divided by secant x. All right, so just like in the previous couple problems, we don't have a rule for antiderivatives that uses division. So we need to split this up in order to answer this. So we can separate the numerator into each term divided by the denominator. So the first term would be secant x over secant x, which is 1. And the second term is tan x over secant x. So that's one step, and we're a little bit closer to answering the question. We still have a fraction here, though, tan x over secant x. And tan x divided by secant x is not any of your derivative identities for trig functions. So you can't really do this as stated. So what we're going to try to do is break down tangent and secant into sines and cosines and see if we can get anything to cancel out. So tangent is sine x over cosine x. And secant x is 1 over cosine x. So you can see here that both of these functions are divided by cosine x, so that can cancel out. And we actually just get 1 minus sine x, or 1 minus sine x over 1, which is sine x. So this fraction actually reduces to this before we've done any antiderivative. But now we're in the place where we can do an antiderivative. So if this is f of x, our antiderivative, we just do piece by piece. The antiderivative of 1 is x. The antiderivative of sine is negative cosine. So since we have a minus there, that would become a plus. Remember that you can always check your work by just doing the derivative of what you end up with, and you always have to get your function there. And in this case, we do. So that underlined portion is our antiderivative of that fraction.
The Teaching Center, UF's Learning Resource Center.